Bum, bada, bum, 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 bum. Okay. And I think we are live.
Yeah, looks like we are live indeed.
Twitch is live. YouTube is not live yet. But that's just like a question of time. There we go. There we go. All right. That's how we start. Anyway, hi everyone, and welcome to today's Continuous Delivery Everywhere meetup. Today we have a double feature coming from Circle CI with Gabriel and myself. So first off, Gabriel is going to be talking about building MSIX packages in a CI/CD pipelines, in a CI/CD pipeline or CI/CD pipelines. And then I'll be talking about benchmarking Android apps performance also as part of CI/CD pipelines. Anywho, this is continuous delivery everywhere. So that's our meetup that we're running at Circle CI. We've been running it for a few months. If you have an idea of what you want to talk about, any continuous delivery related topics, and there are a few or a lot, are more than welcome. Just reach out to me, Zed Markin on Twitter, or Z Markin if you're Northern American, and or email me at zan@circleci.com and we'll book you in. Anyway, we're Circle CI. We're the leading CI/CD platform in the world. We really operate at an enormous scale, serving all the customers, using all the technologies, and building all the software you could imagine. I'm pretty sure that anyone watching this has had at least maybe 3 or 4 pieces of software that they've used, or piece of technology to say it better, that they've used today that has been built or touched on by a Circle CI, which is, really, really cool. And today we're talking about 2 very different types of technologies. So MSIX, the .NET, and Android, obviously, the Android. Anyway, we're live on YouTube and Twitch, so you can watch us there. You can ask us anything using the comments. And of course, if you have any longer questions, or if you just want to hang out with us, we also have a Discord. So circle.ci/Discord. We have a meetups channel where we kind of drop links and things that might be relevant to the community. And that's like obviously very searchable, and it's always there. And you can follow us for any new events that we're publishing on meetup.com. So continuous-delivery-everywhere is the meetup. Anyway, now let us go to Gabriel, and it's your turn.
Cool. Yeah, so let me go ahead and I will share my screen. Hopefully this doesn't combust. That one. Go ahead and share that. Hopefully everyone can see that. So we're going to be we're going to be talking about MSIX, which is sort of the next generation of Microsoft's installers for Windows. So it's an app package format. It's commonly used for what they call their I can't remember the name of it now. The apps that you get from their app store, it's commonly used there, but it's also available to be used as sort of a standalone. You can package, as you can see here, so Windows Form apps, Win32 apps, so your standard executable files. It's really it's a very nice self-contained package. You can pass along a lot of metadata with it, and it's also signed by default, which is something that we will be touching on here. So today we're gonna run through a little bit about the MSIX orb, which is an orb we created alongside Microsoft to make the specific commands that you need to run to create these packages much easier within Circle CI. And we will also be talking about how to create MSIX packages using executables that you build on Circle CI, and then taking that executable and then signing it on your own machines using our Runner product. And I should have brought up a link to this, but Runner is our solution to running jobs on-prem. So you take this little executable, you install it on your server, it listens for new jobs, and then when a new job that uses that runner pops up, it'll download it and run it on your own machine or your own cloud server, or wherever you need to store it. So in this case, we'll be using just a Windows virtual machine here to run our commands. So yeah, let me grab the right one here. Is that one? Yeah. So this is a fairly simple look at what a configuration would look like if you were just building an executable file, packing it into that Apex or Msix installer. I'll be using those two terms a little bit interchangeably. From Microsoft's perspective, the Msix term is newer, but they both use the same file extension. So I apologize if that confuses anyone, but that's just kind of how Microsoft sees it. So yeah. So right off the bat, we're importing two orbs here. These are relatively important. So we've got the Microsoft-Msix orb. That's going to bring in the commands that make it easier to both pack and sign our installer. You'll notice I'm using a dev alpha version here. That's actually because I very recently found a bug in this particular orb that's now been published, but I've forgotten to switch back to that version for this demo. In reality, let me actually pull this up on my other screen so that I can actually demonstrate what it would actually look like. 1.1.1, perfect. 1.1.1. So that's what it would actually look like. You'd actually want to specify as close as possible. And you know what? I'm actually going to share. I'm going to share that specific window so that it's not as small. There we go. That should make it a little bit easier to see on the stream. Zan, you might need to share that. There we go. That should make it a little bit easier to see. So yeah, we're bringing in these orbs. If you're not familiar with an orb, it's our answer to sharing configuration across various projects. So you can bring in executables, you can bring in jobs and commands. So it just makes it a lot cleaner in your configuration. Also bring in the Windows orb because I want to use the Windows executor to build our executable on Circle CI. This is, again, like I mentioned, this is sort of a hybrid approach. So you wouldn't necessarily need to run this build command on Circle CI. You can do it all on your runner machine. But Circle CI, running it on Circle CI does offer some advantages. For example, you could only have this build job run on all commits, and then only have the sign job run on the main branch, lessening the load on your own servers. And you can leverage Circle CI a little bit easier. So yeah, we have this build job, which is using our Windows executor. So it will run in our Windows virtual machine. We have a shell specified here. This is optional, but by default we use PowerShell 5, and specifying PWSH we'll use PowerShell 7, 7.1 something. I can't remember the exact version, but it's relatively up to date. We have just a little checkout here. So this is sort of a, normally you just have, the normal checkout command here, but I'm using a little bit of a different one just for the purposes of demonstration so that I can get all the correct files in. So in this instance, we're going to be building our Circle CI CLI as a Windows executable. We're going to be bringing in some necessary and Msix metadata files. And so these are like the app manifest, which I have right here, and the mapping as well, which maps out how the installer should be packaged up. So yeah, so it just downloads that from a bucket. This won't be live for very long, so I don't feel bad about showing that. And then we just unzip that to an output directory. We'll then go ahead and build the executable and persist it to the workspace so that we can pick it up in the next step, which is where we sign it. So running through this again, we've got our shell specified, machine we've specified as true. This just tells CircleCI to use a virtual machine, but we're also specifying the resource class of our runner name. So in this case, I've got my own namespace here and Windows Dev VM. So that's pointing to my virtual machine where I have Visual Studio installed and all that fun stuff. So we'll go ahead and attach the workspace. So we'll bring in all those files from CircleCI to our local machine. We'll run the msix/pack command. Under the hood, this will run the make appx command from the Visual Studio version of your choice, or not Visual Studio version of your choice, the Windows SDK version. So I'll run that. It'll so we pass through the package name. By default, we will build using a solution, so a Visual Studio solution. In this case, because we're demoing sort of a hybrid approach to building and code signing in Msix Installer, we're going to skip that, but I will show another config where we're using a solution and it just all runs pretty seamlessly. So we're specifying that to false because we're going to be using our own executable. And because that's false, we need to pass in a mapping file and our manifest file. And we also specify the working directory because all the files that we actually want are in that output directory from this previous job. And then we go ahead and rerun the msix sign command. So this is going to run Microsoft Sign tool, and that's what's actually going to take your certificate, your private certificate, and it's going to sign the app installer so that when other people go to install it, it'll pop up as sort of a trusted installer. Msix installers do enforce this a lot more than sort of your standard executable, where it might just pop up that, hey, do you really want to run this? Msix installers won't actually run unless it's properly signed by a certificate that's trusted by your computer. For the purposes of this, I'm just using a self-signed certificate. But in sort of a real use case, you'd be using a code signing certificate that you purchased from somewhere. And typically best practice for that is not upload it online anywhere. Hence the sort of need to have this hybrid approach where you build on CircleCI and then you actually sign it on your local machine, so you can avoid uploading that certificate anywhere and keep it secure on your own machine. And then we just have a basic workflow down here. Does the build, does the sign, requires the build. And yeah, that's a pretty high level look at that. We'll go ahead. I need to open this and we will go ahead and run the runner in our virtual machine. And then we will go ahead and...
Are you showing anything other than VS Code?
I'm about to
cool.
reset my share screen. There we go. Hopefully everyone's able to see that pretty well. So we've got runner running in our... I'm not sure the best way to do that. Let me think.
Command plus. That's all ideas I have.
I can make my terminal bigger,
right.
and I'll make the pipeline bigger as well when we switch back to that. So we'll just go ahead. Status. This is in my testing repository, so we don't have any changes. So we'll just go ahead. Normally, you'd have changes. You'd want to actually make a proper commit, but in this case, I don't have any changes to push up. So I'll just go ahead and trigger an empty commit so that it actually runs through the workflow. And I forgot about that. I will stop my share real quick so I can grab my passphrase. There we go. Share screen again. Screen 1. There we go. It seems to randomly decide that it doesn't want to store that password. So we've gone ahead and we pushed it up. We'll switch over here and we can see our new pipeline is running. Just increase the size of that. So we've got this build running. This will take a little while just because the Circle CI CLI is a relatively large Golang project. So we'll just wait for it to go through here. Preparing environment variables. So while this runs, this should take about 2 minutes, I think. We can take a look at what it would look like if you're building it with a solution. So if you're building it with a solution, and this is the Msix source, by the way, it's completely open source, so you can take a look at it if you'd like. So if we go ahead and we go into the sample
Can you zoom
here.
into this a little bit?
Yep, absolutely.
Awesome.
So if we go into the sample here and we look in the sample, so this is all of these files are generated by Visual Studio. So there's a way to set up a new Apex or new Msix installer within Visual Studio, which will bring you all these files. So it'll give you, the solution file and the sample project file as well. This is something that you'll link to that first project and will actually be your application. So in this case, we have a very simple, just a very simple Visual Basic application. Nothing super special. It just displays an empty box more or less. But the real sort of magic, I guess, is which file was it in again? WA project, I think. I can't remember now. There is something that specifies in here that it is it wonderful artifacts? Yes, here we go. So it specifies the sort of packages that that it will drop. Anyways, the actual files aren't that important because you'd be doing all this configuration in Visual Studio. Is this done? Yeah, perfect. So we head back over here. We can head to sign. You can see that the executor is my namespace Windows Dev VM. If we take a look at the VM real quick, you can see that it's actually gotten that job and it's running through. It's running through all the steps. So we've attached the workspace. And then we're building the Msix installer with our executable. So we're executing our make apex command. We're just using the default parameters here, which is just passing through the manifest, map file, package name. You can pass through your own if you'd really like, but these are sort of the bare minimum for building an executable. We upload the artifacts and persist it to workspace. We then go ahead and sign it. So this is using the sign tool here. And then it's, normally you wouldn't see this. Normally you would see a success message here. I'm not entirely sure why this happens, but I believe it's due to my case of using a self-signed certificate. In either case, this error wouldn't manifest in real use. You would see a success message here. You would get your Apex file, and you'd be off to the races. If we take a look at, so yeah, that's a pretty simple approach to sort of a hybrid building on Circle CI and signing on your local machine, so you don't have to worry about exposing any sort of certificates or secrets. And with Runner, it's just very straightforward and easy. I should mention that Runner for Windows, I believe, is still in preview. I believe we've recently added some docs on it on here. So this is our Circle CI Runner overview. Circle CI Runner is available for everyone on the scale plan. I should have mentioned that beforehand. It isn't available for everyone. We're reserving it for the scale plan. Yeah, so pretty basic overview here. If we go down to, so in preview, we currently have Windows is in preview. If you want to get access, I believe you can just contact us. If you're already on the scale plan, yeah. Contact us if you have questions or contribute. And I believe there should be, maybe I was imagining it. I believe there was recently an update to talk a little bit more about Windows on Runner, but I'll have to find that page later. But if you're interested in Runner, feel free to reach out to us. It's available if you're on the scale plan. Jumping back a little bit so I talked about solutions and Visual Studio and using that to manage your Msix installer. That's sort of a more all-in-one experience. So you'll get sort of your Visual Studio project blobs, and you'll take those, commit them to Circle CI. In this case, you can use that same Runner approach. So you can build everything on Runner, have your certificates locally stored, or you can just build it on Circle CI, which would require you to upload your certificates. In most cases, you wouldn't want to upload your actual certificates. You'd want to upload some self-signed testing certificates. But just looking at this real quick, so we have an MS build restore. Just make sure that everything is set up properly. All the requirements are met. And then we go ahead and build the actual solution. If we scroll past all this logging, so the orb takes care of all of this. It gives us a nice default parameter. If we ask it to import a certificate, so if we if we're running this on Circle CI and not necessarily on our machine, we'll want to import a certificate, which this will take care of. And then it goes ahead and compresses the final result for us as well. So go ahead and take a look. Import certificate, does all the building, and then uploads the artifacts for us. And we can actually go ahead and should be able to download this and then open it up in here. Let me go ahead and stop the share so I can move it to my virtual machine. Window, that one. There we go. So we can go ahead. We've just gone into our app packages.zip. We can see here, if we go into here a little bit, we have this Msix bundle. If we go ahead and we run that, we'll get our nice Msix installer. So this is using the solution. If that executable hybrid approach worked, you would get a very similar result to this, just with some different metadata because we were using a sort of demo Circle CI version. So we just have, a very simple, go ahead and install it. And then it will automatically launch and we just get a blank window. Yeah, it's all relatively simple using the orb. So if we go ahead and view the config, and we go to the source. There we go. So if we scroll down to integration test using solution, it's just really 3 commands. So we've got the checkout, which is, oops, I'm not sharing the right screen again. I'm too used to switching screens in OBS as opposed to having to stop and reshare. So yeah, we've got the integration test using solution. Again, this is for the orb. You might name this a little bit differently if you're using this in your actual project. We're running this in our Windows executor. We go ahead and we do a checkout. We run our MS build restore. And then we just give it the MSIX pack, give it the working directory. We tell it we want to import the certificate, and we tell it what the certificate is, and it takes care of the rest. And that's really all you need to do to build MSIX on Circle CI.
Cool. Awesome. Just like really cool. I mean, how I think you've already kind of pointed to the orb repo, but maybe just like worth reiterating if folks have any questions or issues. Where do they go?
Yeah, so you can go to, we manage all issues and most communication to do with orbs through the public repositories for the respective one. So in this case, you could go to github.com/circleci-public/Microsoft-MSIX-orb. And that'll bring you here where you can file an issue if you have any questions. You can also, if you really want, you can tweet me. I'm at gmem, GMEM _, on Twitter. Happy to take questions there as well. Once you're on this GitHub page, of course, there's links to the org page as well, so you can check out the docs there, and any sort of pull requests and work in progress that we have going.
And obviously, the orb is also, the docs are also discoverable on the developers portal, right? Yeah.
Yes, yeah. So if you go to circleci.com/developer. And you just head over to orbs, and then you can just go ahead and type in MSIX. It'll be right there. It's very, very easy to discover for sure.
So now it's legit. Cool, awesome. If anyone has any questions over in Discord or YouTube or Twitch, I haven't seen any. Yeah, so if there's no questions, going once, going twice, 3 times, nothing. Anyway, thank you, Gabe. This was great. Yeah.
Cool.
And
I'll be keeping an eye on Discord if anyone has any questions there with this or orbs in general.
Cool. All right. Thank you. And with that, we are going to head on to the second segment of today, which will be talking all about Android performance testing. Anyway, yeah, so that's going to be my presentation. I'm a developer advocate at Circle CI. My background is I've done a lot of Android in the past, so this brings back memories anyway. So yeah, speaking of memories, back in 2015-16, so a long time ago, there was a YouTube series and a series of docs called Perf Matters from the Android DevRel team. And they were talking about everything related to how to make your apps performant. They were mostly focusing on the component level. So things like how do you make lists scroll nicely, and how do you make efficient network requests? How do you conserve battery and all that stuff? And obviously, if you're an Android dinosaur, you might have remembered those and some of the memes associated with this. And even if you're not an Android dinosaur, you can still care about performance as a user, and users do care about performance. Just think about yourself. What would you rather use? Which app? If you have 2 apps, one that loads smoothly, like butter, essentially opens up very quickly. Every scroll is super smooth. Animations are smooth. Everything works really nicely. And the other one was this, which is janky, which loads really slow. There's loading screens and so on. I know for myself that I would definitely prefer the first one, even if the services might be a little bit more expensive, if the app itself is more expensive, or is just the user experience is definitely the important thing for many apps, and especially if you're kind of competing with similar apps across what you're building. It's even more important to kind of stand out through excellent UX, and performant apps are that. Anyway, back in 2019, they announced the Android Jetpack, and the part of it was called Performance Library for or Benchmarks for Android Jetpack. So Jetpack is this library that makes making Android apps a lot nicer. And Benchmark is brought the capability to essentially measure performance and benchmark various parts of the app. They were first focusing on something called micro benchmark, which are like these components. For example, I'm doing a network request. I'm scrolling some through some data, and you essentially put some markers around part of code that you wanted to check, and collect the benchmark through repeated runs of that. Now, in this year, so 2021, at Google I/O, they announced macro benchmark, so a revamped and a brand new feature to this, and it's all about this kind of black box performance testing. So things that your users would actually experience, and that includes startup benchmarks. So how long does my app need to start, and not only from the main screen or from the launcher, but also from any other kind of entry point that you might have. For example, you might have a share option that opens your app. You might have an app that opens on a link because of all the deep links that you can implement, and all of that. They've kind of added these capability to do startup benchmarks, and also do things like scroll jank and so on. And there's like a bunch of other things that you can do. Anyway, they have a whole portal dedicated to this. I'll show it in a bit. But let's first talk about why and how you would take this benchmark testing, which is obviously lives in Android Studio, and it's really well implemented in Android Studio, how you would take this into a CI/CD pipeline, and why. Why? Let's start with why. Because you don't want to do this manually. This is not a test that's kind of fast to run. It's slightly flaky because it requires a lot of runs of essentially end-to-end runs of different things. And it's something that you should always be kind of mindful of when you are releasing your app. Is my startup time still as snappy as possible? Is it as quick as possible? Are my screens loading smoothly, and so on? So that's definitely reason to test, and that's definitely reason to test something in a CI and continuous delivery pipeline. So yeah, what we do first, we write tests. Obviously, I'll show the tests in a bit, but they use the same instrumentation framework that you're otherwise used to. And then we obviously have these new tests included as a new job in a pipeline. We need to run those tests on real devices, so such as Firebase Test Lab, Source Labs, Amazon Device Farm, any of those real devices, or your own devices, and definitely not emulators, because you want the performance to matter, be very similar to what a real world example will be. And emulators, the difference between emulators and real devices is that they don't necessarily run with a GPU, especially on cloud emulators. So if you don't have GPU, your screens are going to load way slower than they would have otherwise. So you're not going to get anywhere near real world examples or real world results. So yeah, your results are going to be like meaningless essentially. Then you want to download those benchmark results from Firebase Test Lab or whatever you're using. In my demo, I'm using Firebase Test Lab. And you can then also process them and say, basically, why would we process them? Because we want to analyze whether they are acceptable for us or not. what I'm doing is, in my example, is just using a manual threshold. So I've run the test a couple of times. I know what I'm expecting. I know what a user will expect, and I've kind of set my limits to this. And I'm just comparing against this manual threshold. And the other example they give, actually, in the a slightly older blog post they link to, is like a historical step fitting algorithm that kind of looks for historical data, all of those benchmark runs, and then kind of falls over any anomalies. So if your build is substantially slower than it was before, then you must have introduced something that's slowing everything down in your process. It's definitely possible to do it in CircleCI as well. But yeah, it's something that you need to like fine tune on your thing. But I'll point you in the right direction. Anyway, then we need to pass or fail based on results. So without further ado, let's look at the demo. I will share my whole screen now because I need a whole screen for this. Share screen. And I'll do a window. No, I'll do the entire screen. Screen 2. Cool. This should be nicely visible. Anyway, again, I have an example for this in this repository, CircleCI-public, and Android testing CircleCI examples. Actually, let's go to that repo. So we're in this branch, and it's actually going to be merged. Oh, snap. I forked it from here, but not. Yeah, this is the one. And it's going to live in the main branch, but for now it's in Ftl Benchmarking. Yeah, here we go. Yeah, you can follow along this. This is the whole example. Android-testing-CircleCI-examples in CircleCI public, same repo as Gabriel showed before. Yeah, so let's look at the code. First off, this is not going to be the most visible thing in the world, is it? Well, let's do this. We'll open this in Visual Studio Code because I can zoom into that. And it's going to be a lot nicer. Close others. I'll close these two as well. Right. So a pretty standard Android project. So we've got one app module, and it's got a couple of things in there. It's a to-do app. It's taken from a code lab, so nothing special with this. Obviously, we've got a build Gradle in here. And we have to add a couple of things in there. And then there is a new module called Macro Benchmark, which is the test module that we added. And this is how you kind of test this. Why do you need a separate module? Because in order to benchmark something, you need to benchmark it from outside. If you're benchmarking the app as a black box. This is Visual Studio is very needy. So you're essentially testing an app as a black box from outside. So that's why I create a new module and kind of run the tests from this module that interact with the app. The app is automated or interacted with using the UI Automator framework. And yeah, you can just kind of, it's part of the instrumentation framework. So it should be familiar to you if you've written any instrumentation tests for Android. The plugin that we're using for Gradle is com.android.test. And obviously this is all well documented in the documentation that I linked to in the slides. which I'll show you in a bit. They've got a step-by-step guide for how to set this up, and this is just like a brief overview of what to expect. You are interested in the release signing config because you want to create an app that's as similar to the real app. So it has to be released, and obviously the tests need to be debuggable. And yeah, there are a couple of experimental properties like self-instrumenting that you need to enable, and you need to pass in the target project path where your app actually lies that you're going to test. And that's pretty much it. Yeah. The other thing is, yes, set up all the testing dependencies as implementation dependencies and not test implementation, because it's a test module. So everything by default is an implementation because it's a test. Anyway, the app, in the app, we've essentially just, I think we're just added, I don't think, no, we've added the signing config for the release app because we didn't have it earlier. So we're signing it with our debug config, because this is not a real like app that's kind of shipped. And that's pretty much all. There's a couple of things you need to also add to the Android manifest of each of those. And that's in source, isn't it? That should be in source. So yeah, you kind of need to add like intent filter for the activities you want to launch, because that's how you're gonna get into the app. Obviously, if you got the intent filters for like share, that kind of stuff, you already have those. But if you don't, that will help you test. And you add profilable, and you need to suppress element not allowed. It's just the thing that they do. And in the macro benchmark module, you just need to kind of provide permissions for external storage, because the tests need to be stored somewhere, and it's best to just kind of use the SD card that's available in those kind of cloud devices that we're using. So yeah, everything. Let's look at the test. So the tests are not in the app module. The tests are all in the macro benchmark module. And I've just got the startup benchmarks. And that's, we need a macro benchmark rule. We need a couple of startup timing metrics, startup modes, and pass in the target package. And essentially, you tell it what to start, and then using that macro benchmark rule, measure that startup that we're defining here, because this is like a parameterized test that runs it on either warm, cold, or hot startup. Difference being whether the app exists in memory or not. And cold is obviously completely like fresh start. Warm is app that's been around, that's kind of lingering around, but not quite live yet. And hot is if you've just navigated out of it and just kind of came back in. That's the difference between the two. And they're going to start at different speeds as well. So cold start is going to be the longest running, and warm start is going to be the middle one, and hot one is going to be fastest. You pass in how many iterations and what the intent is going to be. And then it just kind of like measures is based on these profiles, and runs this test. So press home, start intent, start activity, and wait. And that's really all you need to do. And it's it's pretty straightforward. You can do it for any activity, any start activity. And if you've got any obviously extra payloads, you can just pass it in here. And this is like more or less copy pastable example. You just pass in your kind of your actions, your package names, and it's going to pretty much work without much effort. So it's like a very cheap thing to add, quick thing to add, and it might really kind of help you catch some user-facing issues. So we've got this, and actually, let me show you. Let me show you this documentation for benchmarking. So this is the link I showed you before. This is all on the Android Studio micro benchmark, macro benchmark thing. Obviously looking at the macro benchmark here. But yeah, you've got steps for how to install this, how to run this. And yeah, everything is in there. You've got a continuous integration steps in there. Can explain how you could run this on CI, but obviously you've got me, so you don't need that. Yeah, so let's look at the config. So this is my application configured, project configured Circle CI. So I've got a single workflow that's called test and build, and I've got a few jobs, some that you're not probably interested in. So running UI tests, and then obviously we're looking at benchmarks. So I've got 2 benchmark jobs. One is for Firebase Test Lab, one is for Emulator. I'll show the difference between the two. Yeah, my 2 jobs, they're essentially, there we go, benchmarks Emulator and benchmarks Ftl. So specify the executor. This doesn't need to have any emulators for Firebase, at least. Like it just needs the Android SDK. So Android orb that runs on Android executor that runs in a Docker container will work. Passing in the SDK version. One thing with this is it only works on SDK 29 or 30. So you need to specify min SDK for the test app to be for the macro benchmark module to be 29 or above. I'm using Node variant of the Docker image because I've got a script that processes some data afterwards that's written in Node.js, so it's like super convenient. So yeah, check out restore Gradle cache and restore build cache. That's pretty standard stuff that you're using in Gradle. And then we're running a couple of assemble tasks in Gradle. So building both the app and the test app. So app assemble release and macro benchmark assemble. We don't need assemble release in this because we're just focusing on the release flavor, but or build type. But yeah. And then because we're using Firebase, we need to initialize our Google Cloud CLI. And this is actually coming from the GCP CLI orb, which we've also kind of defined here at the top alongside the Android orb. So, so orbs are our reusable bits of config that kind of save you a lot of stuff. Like, for example, for Android orb, we have doing things like Gradle cache cleanup and restoration, and also starting the emulator, if you will, and also for Google Cloud, we've got the initialization. So all the project, all the API key stuff is kind of done for you. You just specify the environment variables where everything is, and that's it. So yeah, that's what this initialize does. Then we need to run another command, which essentially runs our tests on Firebase Test Lab. And this is the gcloud Firebase test Android run. It's a handful, I know. We're specifying it's an instrumentation test. Again, this is very standard Firebase test lab command. It's you just kind of specify the app, you just specify the test app if you need to. Device model, I think Flame is code name for Pixel 4. Locale orientation, all that stuff. And then we pass in directories to pull, so which directories to actually download from the app. Result bucket, so this is a Google Cloud Storage bucket. I've created this one, I own this one, and it'll kind of pull the data into this bucket, into this directory. I like to specify directory just because it allows us to then like directly go into there without navigating and knowing where exactly my files are, because otherwise it just kind of creates a new folder that's based off device name, I think, and timestamp and some random hash. So by just specifying your own folder, you avoid that. And any environment variables you want to pass in. So clearing package data, additional test output directory, and yeah, no isolated storage. That's all we need to do. And then this will run, and I'll show you a run in a bit. And then once we have this, we basically use the Google Storage util. Again, this comes from the Google Cloud SDK or Google Cloud CLI tool. We specify the path to this. So enter sample benchmarks. This is my bucket. Macro benchmark, the directory it's in, and then the path to it. And I can tell you, it just located in here. The two asterisks here are actually the device type. So Flame, Portrait, version 30, something like that. Anyway, they're located in here. I'll show you. Actually, I've got the outputs in here. This is an example of the output folder. So we've got the JSON file and then a bunch of trace files, which are binary that you can use in Android Studio. Will understand how to read them. Yeah, and we are removing that directory afterwards because we don't want older trace files in there spamming us when we're kind of storing those artifacts. So store artifacts is a Circle CI command. So we've created this benchmarks folder and we've kind of copied them in, everything in there. And then we're just storing this as job artifacts. So they are living in Circle CI. They're copied in here and they are available for us to then evaluate. And evaluate benchmark results, it's essentially a script. And as I said, it's a Node script. I like Node, and we're dealing with a JSON file. So it's like the easiest thing to do. Obviously, you can use whatever you use. Yeah, you pass in, well, I pass in my path to my data. So home Circle CI benchmarks, and then it's always going to be this name based on my application package name. And then I kind of set my threshold for cold startup, for warm startup, and for hot startup. So if my test, essentially, if any of those startups is slower than this value, so cold startup is slower than 250 millis, I'm going to fail the test. And yeah, and this is just like console log. And in order to fail the test, actually, we want to kind of call process.exit, which will give us an error code, which we're either setting to 1 if we're kind of over the threshold, or keeping it 0. If Circle CI runs a process that terminates with a non-zero exit code, so like 1 or -1 or whatever, it is going to fail that job. So that's the logic we're following here. So that's it. Let me navigate to Circle CI now and show you an example of this. It's conveniently named fix typoi. because typos are fun. So you can see from the get-go that my Ftl benchmarks run a lot faster than my emulator benchmark. It's just three minutes longer, but this compounds from each run. So Ftl benchmarks, again, this does all the, this is coming from orb and run on Ftl. It basically gives you like all the tests are by default going to pass because there's nothing that it actually asserts. Is just kind of running the test. If they crash, if it crashes, they actually fail. But if it doesn't crash, it's always going to pass from what the Firebase Test Lab is concerned. Anyway, and yeah, then we're downloading that benchmark data. So we're copying it using the tool and then uploading as artifacts and then evaluating my benchmark results. And you can see that cold metrics, warm metrics, and hot metrics are all under the median time that we've allowed. All of that is available in that JSON file. And we can actually go into it and see everything about the device, everything about the hardware that's available for us, and all the benchmark that's running. So cold, startup, all the runs, minimum, maximum, median. So all of that is available to us here. Yeah, so that's kind of where we are. That's kind of where we are. Yeah, let me show you. Let me show you the example of not of the emulator benchmarks. So they would be slightly slower. By slightly, I mean a lot slower. So if you're thinking about this, this used to be like less than 100, and now it's like 2,800. So 2.8 to 5 seconds, basically. So a lot slower startup times you get on an emulator just because of that kind of difference between hardware support for GPU and all of that. Now we do have virtual machines that are supported with that have GPUs available, but yeah, they're only available I think on scale plan, and yeah, I think for these types of tests, actually Firebase Test Lab is better because it gives you like real devices as opposed to emulated devices. Anyway, so yeah, and now we can be sure that actually I've got a failure here. I've got a failure here, which was like, yeah, over the threshold. So I've increased the threshold later. And this is something that's enough for you to say, okay, why are my tests slower? How do I get around this? And yeah, so that's basically it from my perspective. As I said, you can find the examples in CircleCI-public Android-testing-CircleCI-examples. I'll copy this over into Discord as well so that you can find it over there. Yeah, resources, as I said, developer.com. This is actually coming as a blog post as well very soon in the next couple of weeks. So all this sample plus the write-up are going to be available as a blog post. The CircleCI project that's relevant for this, and Google's own repository that I kind of borrowed from to create my own sample. Anyway, this is it. If there's any questions, I would love to answer them. If not, I hope you've had an interesting hour or so learning about MSIX and Android performance testing. If not, we'll publish a new event in August, hopefully. If not, in September, depending on availability of speakers, essentially. Yeah, thanks for attending today's continuous delivery everywhere event. And yeah, I hope to see you again soon. All right, thank you.